Hi, I'm meteorologist Jennifer Perez, and this is What's Up with the Weather. Today I'm talking about one of the most dangerous weather threats, tornadoes. Did you know, on average, the U.S. averages right around 1,300 tornadoes every year? That's on average here in the U.S. The state with the most tornadoes is Texas, right around 140 tornadoes. Then comes Kansas with 80. On average, 80 tornadoes. Florida gets on average 59 tornadoes every year. Oklahoma gets 56. In Missouri, 39. And here in our home state of Michigan, we usually get right around 16 tornadoes every year. Now, in the UP, we typically get one tornado every year. The tornadoes that we see here in Michigan, in the UP, or even in the Great Lakes are the weaker ones. Those are usually rated EF0, EF1 to EF2s. The stronger, more violent, and long-track tornadoes usually occur in Tornado Alley, places from Texas all the way up through parts of Iowa and Nebraska. But tornadoes are more common in supercell thunderstorms. And for those thunderstorms to develop, we have to have a specific set of ingredients in place to help build and form into a supercell thunderstorm. These are the ingredients that you need within the environment to help support supercell thunderstorms. You need dew point temperatures greater than 55 degrees Fahrenheit. So you need a lot of Gulf moisture. Ideally, ripe conditions and juicy conditions as far as moisture is concerned. We would see dew points at least in the 60s or higher. Then you need energy. So you need a lot of solar radiation heating up the Earth's surface, providing a lot of fuel for those thunderstorms to develop and to continue to grow and stay strong and healthy. And then you need wind shear, which is a change in wind direction with height and a change in wind speed with height. And then finally, you need a forcing mechanism. You need something that's going to help lift that warm, humid air up vertically into the atmosphere. So a front of some sort, a cold front, a warm front, a dry front of some sort to help lift that up. Now, as far as the supercell is concerned, here's a recap of what it looks like. You have the warm, moist air coming in from the ground, so that eventually turns into the updraft. You have the downdraft, which is an area of rain-cooled air in the front portion of the supercell. This is called the forward flank downdraft, and then you have the rear flank downdraft, which is rain-cooled air, but this air is just a little bit warmer as compared to the front one. And you have the anvil, the overshooting top, and then you'll have the flanking line of popping up cloud cover behind it. So this is a setup for supercells and how that supercell looks. But at the ground surface, I think the key is the winds. Once you have the energy in place, you get the winds, and that kind of helps create the rotation. So this is how it sets up. You generally have winds out of the southeast at the surface. Then in the upper levels, you have wind flow out of the west. So you have two opposing wind flows, okay? One out of the southeast and then the one in the upper levels out of the west. And what that's going to do is it's going to create rotation at the surface. So it's going to rotate the air that's at the ground and at the surface, and it's going to create a horizontal tube of rotating air. It's invisible. You're not going to be able to see it, but it's there. Once a thunderstorm moves over this tube of rotating air, what's going to happen is it's going to lift it up vertically into the atmosphere and into the storm. Okay, so it's going to take a lot of that warm, humid air that's in this tube of rotating air. It's going to lift it vertically, and once it does so, it kind of ingests it, and it then becomes a rotating updraft. So rotation continues to increase within this supercell. It is at this point where we call it a mesocyclone. Once that continues in place, it's at this point that that warm, humid air that's being ingested from the ground rapidly cools and condenses it turns into a wall cloud, which is a lowering of the base of that supercell. And it's usually at this point where we reach the highest rotation within the supercell. At this point, that's when you will likely get the development of a tornado. If it develops, you'll eventually see the vortex coming down, all the way down, reaching the surface. And if it does, it's called a tornado. If it does not, it is called a funnel cloud. Now, the way that we measure the strength and damage of a tornado is based on the enhanced Fujita scale. And it ranges from an EF0 to an EF5. With the enhanced Fujita scale, it takes into consideration the wind gusts for every 3 seconds, for every consecutive 3 seconds that wind gust is going. So the EF0 is minor damage. It is the lowest on the scale. Wind gusts will push up to 85 miles per hour. And if you get an EF0, usually, the damage is minor. You would tend to see some branches that are on the ground that get snapped, or you get a little bit of roof damage or siding that has been damaged a little bit, but nothing major. Then comes an EF1 that's set at moderate damage with wind gusts of up to 110 miles per hour. Then there's an EF2, which is considerable damage, wind gusts of up to 135 miles per hour with an EF2. An EF3 is considered severe damage. Wind gusts will push up to about 165 miles per hour. So with an EF3, it is at this point where you tend to see a lot of buildings with multiple levels collapse. So those different levels will collapse towards the ground. It's also at this point where you usually will see cars get lofted up into the air and thrown miles away. You start to get projectiles into the air as well. Then comes an EF4, that's extreme damage with winds gusting up to 200 miles per hour. And then finally we have an EF5 scale rating for a tornado. That is massive damage. That is total destruction. Wind gusts are in excess of 200 miles per hour. And remember, these wind gusts that are used to measure the rates of damage within this scale, those are per every 3 seconds. So count for 3 seconds. So it has to be 3 consecutive seconds of this wind gust speed in order for it to be rated at this level. So again, with an EF5, massive damage, total destruction. Everything is leveled. Trees are completely debarked. Cars have been completely lifted and thrown several miles away. It's just incredible devastation. So that does it for tornadoes and how tornadoes form. The next one, we're going to cover weather safety tips.